Hey, so we're picking back up here. We just finished talking about circumference and arc length or length in general. You're talking about how long something is. Of course, that's not too far from talking about area. So we're talking about area of and in circles. Let's go ahead and start with an easy review problem from something that you may have done even in lower grade, middle school, that kind of thing. All right, let's say you have a circle here, and I'm going to run a diameter. That's not the best one, but if I make my center bigger, it'll kind of appear that that is the diameter of the circle, and this diameter is 6 inches. All right, diameter of my circle is 6 inches, and we want to find the area of this circle. So the area is pi r squared. If you remember that formula, area is pi. R in this case would be 3 because it's half the diameter, and you square it, ending yourself with 9 pi, which to the nearest tenth, I like to give you both 28.3 in its area. So we take the inches and we'll square them, inches squared. All right, so this is finding the area of a circle. Not so bad. That's basically saying, okay, if I could shade in this area right here, all of this, right, all of this in here, right, trying to stay in the lines, would be 28.3 inches squared, or 9 pi inches squared, whichever way you want to look at it. All right, that's the area of a circle. Now we're going to start finding the area. That's the area of a circle. Now let's find some areas inside the circle. Let's talk about two very important types of areas that we're going to want to find. Let's clear this out. Start with a new circle. This circle, it's in yellow. I definitely don't want it in yellow. Let's put it in black. Sorry for the delay. There we go. Okay, so we want a circle here, and I am going to start off with my center, and I want my diameter to run through it. And I'm going to do a little radius right here. And a lot of times what they'll do is they'll put some information. They'll put some information on your circle, like, for example, this is 60 degrees. They'll say that this is 5 meters. But then they'll say, find the area of the shaded region. What region do you think they may shade? Let's put it in purple, one of my favorite colors. Find the area of this shaded region. That's what they want you to find the area. And it seems that the information is in some random spot. Now, from our earlier videos, we learned that this shaded region, it is known as a sector. So they want us to find the area of the sector. And the sector, kind of like we said with the arc length, this is just a fraction of the area in this case. So the sector is a fraction of the area. That's what they're asking to find here. So we're finding the area of a sector. And what is a sector? A sector is just a fraction of the entire area. Well, that fraction, just like we just finished, is the measure of the arc. Since I don't have an arc name, I'm just write that in shorthand. Measure of the arc over 360 of its multiplication. And then the area we just worked through was pi r squared. So now I have to figure out these different pieces, the measure of the arc and the radius that I need to substitute in. So what is the measure of this arc? Well, if this is 60 degrees, and we know that this is a straight angle, these are a linear pair, so this would have to be 120. 120 over 360 times pi r is straightforward, given to us is up this part right here, 5 squared. So 120 over 360 would be 1/3 of the circle, a third of 5 squared, which is 25 pi. And sometimes this is written 25 over 3 pi like that, or to the nearest tenth, 26.2, and this is in meters, and it's squared. right, if it's to the nearest tenth. If not, you can leave it 25 over 3 pi meters squared. That is the area of that sector. Let's move on. One more example that I want to show you. Sometimes they ask you to find, if you remember on the video where I talked about the central angles and these parts that come off of the central angles, sometimes they'll also want you to find not just the area of the sector, but the area of a segment. All right, so while I'm finishing drawing this, and you can draw this with me, you'll recall that segment is used just like this segment I'm drawing here, that's a diameter, but segment can be used in more than one way. It can also be used like this part that I'm getting ready to shade up here. Let's say if we had this shaded portion right here, that this would also be called a segment. Now, I know they're talking about this type of segment versus, say, the radius or the diameter type where you have two endpoints, because you would not be able to find an area of anything that would be like a line segment. But in this case, this type of segment, it makes sense. So you kind of have to use your context clues. It's like if you hear the word for, depending on how you hear it, you know, if you're talking about a number or you're talking about FOR for, like you're doing something for someone, you know the difference of what they're talking about. So let's say the area of the segment that you know you're talking about this piece of a sector. It's a part of the sector right here. Let me finish putting the information inside of here because that's where we want to find, but we got to have some information to be able to do it. Let's say we know that this is 120 degrees and that this diameter is 8 feet long. If they want me to find the area of this segment, I first have to figure out what the makeup of a segment is. The makeup of the segment is this sector, and outline it in red, is this sector right here. All right, so it's the sector, and you'll need to subtract or get rid of this white space. And what is that white space? Like, what could you call it? Well, the white space there is the shape of a triangle. So minus the triangle. Okay, so the area of this segment is this sector minus the triangle. Well, let's do the sector work first. That's what we've been working on. So the sector work is a fraction, so that's something over 360 of the area, which is pi, and then r would have to be half of 8, which is 4 squared. And this fraction is 120, as we see inside of the central angle. So that simplifies to a third of 16 pi, or just 16 over 3 pi. We've got that piece. So it's the whole thing, this whole sector, minus the triangle. Well, let's deal with the triangle. If I have the triangle, let me pull it out of the picture here. All right. So it's not the most wonderful triangle there, but I pulled it out of the picture. These pieces right here form the radius. So this is an isosceles triangle because both of those are radii. They're both 4. And so when I drop this piece here, because I know I'm going to need that to find the area of the triangle, I'm also going to need this piece right here. But one thing I know about it is that this will be an altitude. It'll be a perpendicular bisector to this piece over here. And that's exactly what I need, because the formula for the area of a triangle is 1/2 base times height, as we did in the previous unit. 1/2 base times height. Now, this was told to us to be 120 degrees. In an isosceles triangle, it's also an angle bisector, making that 60. So I have a 30, 60, 90. Where this is the hypotenuse, and this height right here that I need is the short leg. So to go from the hypotenuse to the short leg, it is cut it in. You get it by cutting it in half. So 1/2 the base. Let me leave space for the base because I don't have it yet. The base is this whole bit right here, from here to here. But the height can be cut, can be found by cutting that 4 in half, which is 2. I'll place it in my equation. So if this is 2, then to get to the long leg, I multiply by, if you remember, 2 radical 3. And this is also 2 radical 3, or 2 square root 3. So when I put it together, the whole base is 4 radical 3. Where then the 2's, the 1/2 here and the 2 there, will cancel one another. So you have 16 over 3 pi minus 4 radical 3, because that's in its most simplified form. So if I put parentheses around there, I could end right there. That is the area of my segment. Not so pretty, but that is the area. Let's say we wanted it to the nearest tenth. I could put this all in my calculator. I'll get 9.8 feet squared. All right, we'll get plenty of practice with this in class. I'll see you later.